Hey guys, this is that second video on inequalities, and this time I'm going to show you how to solve linear absolute value inequalities. Let's go. Hey guys, and welcome back to this second video on inequality. Go ahead and subscribe, it's free, and share this video with anyone you think might need it. Today we are going to be focusing on solving linear absolute value inequalities. And you can do this in two steps. The first step is to consider solving the equality version of your problem. And the second step is to check your region so you can figure out what your answer would be. All right, so let me give you an example so you see clearly what I mean by that. So let's say you're given something like absolute value of 2x minus 6 less than 8. So when you have this problem, the first thing you should do is rewrite this problem in equality form so you can solve that first. And so you're going to have 2x minus 6 equals 8. And so to solve this, you have to consider the positive and negative side of your equation. So you're going to have 2x minus 6 equals 8, or 2x minus 6 equals negative 8. And so if you want a refresher on how to solve absolute value equation, check out my note number 13 where I talk just about that. And so the next thing we need to do here is solve both of these equations separately. So we're going to have on the left side here, if we add 6 on both sides, that will give us 2x equals to 14. And finally divide by 2 on both sides, and that will give you x equals 7. On the right side here, we add 6 on both sides, giving us 2x equals negative 2. And finally divide by 2 on both sides, and you get yourself an x equals negative 1. All right, that's step one. And since this step one, solving the equality version of our problem, is done, the second step is to go ahead and actually check our region to see what our solution would be. So what you need to do for that is draw a number line and put those solutions that you just found on it. So I'm going to have to put here negative 1 and 7. And then the next thing you need to do here is check each of those regions to see if they satisfy your original problem. Because inequality problem is all about dividing the number line into pieces and then figuring out which piece actually works out for your problem. So by solving the equality version of this problem, you'll find out the boundaries of all your region, and then after that, you get to decide which region actually works out for you. And so right now, as you can see, we have 3 different regions to work with. The first one is from negative infinity to negative 1. The second one is from negative 1 to 7. And the third one is from 7 to infinity. Now we just need to pick out numbers in each of these regions to test in our original problem. So let's look at the first region here, for instance. If I wanted to check a number here, I will pick, for instance, negative 2. One thing that's important here is that you should not pick the actual numbers that are dividing your region, i.e., negative 1 and 7. So for this first region, I'm picking negative 2 to be my test point. And so I'm going to go ahead and plug negative 2 into my original equation and see if that works out. So I'm going to have the absolute value of 2, in parentheses negative 2, minus 6. Is that less than 8? And so 2 times negative 2 is going to give me negative 4. Minus 6 will give me negative 10. And in absolute value, that should give me 10. And so I'm going to have here 10 less than 8. And as you can see, this doesn't work out. So I can cross out this region because it's not good. In the next region here, I'm going to pick out 0. And so if I pick 0 as my test point, I'm going to go ahead and plug 0 into my original inequality. And so I'm going to get the absolute value of 2 times 0 minus 6 less than 8, question mark. And so that will give me 2 times 0 here is going to be 0, minus 6. In absolute value, it's going to be 6. And so what I have here is 6 less than 8. And that's true. So this second region here is good. And the final region is going to be from 7 to infinity. And there I'm going to pick 8 as my test point. And if I do that, I'm going to get 2 times 8 minus 6 in absolute value. Is that less than 8? And so 2 times 8 is 16. Minus 6 is going to give me 10. In absolute value is still just 10. And so I'm going to have 10 less than 8, and which is not correct. So I'm going to also cross out this particular region. And so finally, I can see that my answer has to be that x should be stuck between negative 1 and 7. And so I'm going to write my final answer as negative 1 less than x less than 7. Now, if you notice, I have 3 regions here. And the region's validity is always going to swap from no good to good after you pass the boundaries. So if this first region is no good, the next one will be good, and so therefore the next one won't be, and so on and so forth if you have more than 3 regions. And so a quick way to check your region here, what I do usually is I'm just going to go ahead and look for the region that contains the number 0, since that's easy to plug in and test. And then after I test 0 and I figure out, oh, this region that contains 0 is a good region, and so I know that I need to alternate this with the other regions and get my answer really quickly. Let me show you another example where we're going to do just that. And so now I'm going to give you the absolute value of 5x minus 2 bigger than 13. So first thing first, let's solve the equality version of this problem. So we're going to have absolute value of 5x minus 2 equals 13. Considering the positive and negative side of this equation, we're going to have 5x minus 2 equals 13, or 5x minus 2 equals negative 13. On the left side here, we are going to have to add 2 on both sides, giving us 5x equals 15. Then divide by 5 on both sides, giving us x equals 3. On the right side, we're going to go ahead again and add 2 on both sides of our equation, giving us 5x equals to negative 11. Divide both sides by 5, giving us x equals to negative 11 divided by 5. Second step is to check our region to see which one satisfies our inequality. We're going to have a number line here, put the 2 numbers that we found as our solution for the equality version of this problem, negative 11 over 5 and 3. Then if I look here, the 0 is found in the middle region here. So I'm going to go ahead and test 0 into my original inequality. That would give me 5 times 0 minus 2 in absolute value. Is that bigger than 13? Well, 5 times 0 will give us 0. Negative 2 in absolute value will give us 2. Bigger than 13? Well, that's not true. What that means is that our middle region here that contains 0 as our test point is not going to be good. And so therefore, the other region would alternate. And so the first region here should be good, and the last region here should be good as well. And so that would give us x is less than negative 11 divided by 5, or x is bigger than 3. And we are done, right? So the reason why we don't need to check all 3 sides here is because our absolute value inequality is linear. And so we're always going to have this alternating pattern whenever you have something linear. If you had something more complex than this, let's say if you had a quadratic inequality or a rational inequality or anything like that, then you have to be careful to check all the sides just to make sure. Okay, final example here in this section, example number 3, you're going to have 4 plus absolute value of 3 minus x over 3, all that bigger than or equal to 9. First thing first, let's solve the equality version of this problem. We're going to have 4 plus, in absolute value, 3 minus x over 3 equals to 9. First thing first, let's subtract 4 on both sides of our equation. And so that will give us absolute value of 3 minus x over 3 equals to 5. Then let's consider the positive and negative side of our equation. That will give us 3 minus x over 3 equals to 5, or 3 minus x over 3 equals negative 5. On our left side here, we're going to do negative 3 on both sides of our equation, giving us negative x over 3 equals to 2. And finally, multiply the whole thing by negative 3, giving you x equals to negative 6. On the right side, we're going to do the same thing. Negative 3 on both sides of our equation will give us negative x over 3 equals to negative 8. Multiply the whole thing by negative 3, giving us x equals 24. After solving the equality version of our problem, our step 2 will be to check the regions to see which one actually works out for our original inequality. And so putting negative 6 and 27 on the number line, we're going to go ahead and check the middle region here that contains 0 into our original inequality, and we're going to get 4 plus absolute value of 3 minus 0 over 3 bigger than or equal to 9, question mark, and 0 over 3 should give you 0, and so that in absolute value should give you just 3, plus 4 will give you 7. And so you have here 7 bigger than or equal to 9, which is not true, which means that our middle region here is gone, which means that our first region and third region should be okay if we alternate. And so our final answer here should be that x has to be less than or equal to -6, or x has to be bigger than or equal to 24. And also notice here that if your original inequality has an or equal sign, then your answer should also have an or equal sign. So that's it, and I will see you guys next time. Alright guys, that is it for now. The link for this note is always going to be in the description below. If you like this video, don't forget to share, like, and subscribe. Also, follow me on my other social platforms on Facebook, Instagram, Snapchat, and Twitter at Franck's Note, and I will see you in the next video.